Okay, next one. Here we're asked to find the probability of not rolling a 4 or 6 on one roll of a 6-sided fair die, numbered 1 to 6, and then we're asked to give the probability to the nearest hundredth. Okay, so the first thing would be to determine what probability principle you're going to use. The giveaway here is the word not in bold. Remember that the word complement means the chances of not getting something. So we're going to use the idea of a complement here, but I would label this question as just a simple probability question. We're just going to look for, we're not going to have to use mutually exclusive or independent, we're just going to look for a simple probability. Simple probabilities mean we're just going to basically look for favorable outcome, so whatever's the thing we're looking for, over the total outcomes. Okay, and that's the probability of our event. In this case, it's going to be a 4 or 6. I believe, yes. So we're looking for the probability of a 4 or a 6. Now the reason I'm looking for the probability of actually getting it is because all I need to do is go 1 minus the chances of getting it to get the chances of not getting it. Okay, so first let's figure out the probability of getting a 4 or 6. I can either, there's only 2 possibilities, so my favorable outcome is 2. It can either be a 4 or 6, so there's 2 successful outcomes, if you want to call it that. Now what are our total? Well, read carefully. It says it's a 6-sided die, so there's 6 total choices. Okay, so if I put that in those terms, I'm just left with 1/3. This is the chance of actually getting a 4 or 6. Going back to the question, it says, what are the chances of not getting a 4 or 6? Well, just go 1 minus this, because if this is the chance of getting it, then everything else is the chance of not getting it. So 1 minus 1/3 gives me 2/3. So of the 3 out of 3 total, 1 out of 3 is getting this option, and 2 out of 3 is not getting it. Okay? So if you look at your options there, your chances of not getting it, some numerical response, it wants it to the nearest hundredth. So we can't leave it like this to put it in if it was actually on the diploma. So all you need to do is convert that into a decimal. Put 2/3 in your calculator, and this will become 0.6666 repeating. It wants it to the nearest hundredth. So you just round this one up and you put in 0.67. So the correct answer for this one, 0.67. For the final question, it says one letter is chosen from all the letters in the word Toronto. What is the probability that this one letter is a T or an O? The giveaway for what type of problem this is the word or. Also, it's one letter being chosen. For mutually exclusive questions, it's usually a single event, and they're usually asking, could the event be this or this? And we talked about in class how sometimes it can be both at the same time, and then it's not mutually exclusive. I also mentioned that they won't actually give you calculation problems like that. So the giveaway is the word or, mutually exclusive. So we immediately know that somewhere we're going to be using our mutually exclusive formula, which is P of A or B is P of A plus P of B. So if it's an or question, you just add the chances of getting this event to the chances of getting this. So all we have to do is add our probability of getting a T to our probability of getting an O. If I write out the word Toronto, saying T or an O. So first off, how many T's are there? 1, 2. So we have 2 T's. How many O's do we have? 1, 2, 3 O's. Okay, so to find our probability, a P of a T or an O, I'm going to add my chance of getting a T. Well, my chance of getting a T is there's 2 of them. And remember, it's 2 out of the total. So how many total letters are there? 1, 2, 3, 4, 5, 6, 7. So I have a 2 out of 7 chance for the T. I have a 3 out of 7 chance for the O. So my answer to this is going to be 5/7. Okay? Which is D.